In this video, we're going to look at finding the axis of symmetry in 3 different ways. Finding the axis of symmetry is connected to using the quadratic formula, and there is another video that talks more in depth about the quadratic formula. I'm going to refer to it here, but I'm not going to explain what it is. If you want some more information, or if you want to watch that video first, you certainly can, but you should be able to follow what we're doing in this video, even if you haven't looked at the quadratic formula yet. So let's jump in. Finding the axis of symmetry requires remembering what the axis of symmetry is. You want to remember that it's just a line that goes through the center of a parabola. So this is my little parabola here. It's a line that cuts through the center of the parabola, dividing it exactly in half, and it's going to go through the vertex. So it's a vertical line that cuts my parabola in half. I'm going to draw a little sketch because the first method of finding the axis of symmetry is just reading it off the graph, probably the easiest thing I could imagine doing. So here's a little sketch, and I'll go 1, 2, 3 to the left, and 1, 2, 3, I think 4, maybe 5 over here to the right. I'll go down 1, 2, 3, and up 1, 2, 3. Alrighty, and let's put a parabola that goes through 2 and 4 on the x-axis. And maybe it comes down here to -2. Oops, and then zooms back up again. So looking at the graph, let's say that the vertex is at +2, +3. There we go, +3, -2. That's where my vertex is. So the axis of symmetry would be a line that goes straight down the middle and straight through the vertex. There it is. It's a vertical line. And because it's a vertical line, its equation is going to have the form x equals some number. And what makes this problem a total walk in the park is that number is the x-coordinate of the vertex. X-coordinate of the vertex. So in our case, the x-coordinate of the vertex is 3. That means that the axis of symmetry's equation, axis of symmetry's equation is x equals 3. And I am done. That easy. So if they've given me a graph and I can locate the vertex, I can easily write the axis of symmetry's equation. It's just going to be x equals whatever the x-coordinate of the vertex is. In our case, it was x equals 3. If they just tell me what the vertex is, I could also write the axis of symmetry's equation just as easily. So maybe they tell me that the vertex of the graph of some parabola is -3, -1. So maybe I might do a little sketch, always a good idea to do to kind of have a sense of what's going on. So I'll go to the left 3 and down 1, and there's my vertex. Now I don't know whether this graph is opening up or it's opening down. I don't have that information, but I don't really need to know that information to know what the axis of symmetry is, because whether it was opening up or opening down, the axis of symmetry is still going to be the same vertical line. It's going to be a vertical line that goes right through the vertex. So the equation of the axis of symmetry, is always a vertical lines equation, which is x equals some number. And that number is always the x-coordinate of the vertex. So the equation of the axis of symmetry is x equals -3. Cake, cake, cake. If they don't give you that information, they don't tell you what the vertex is, or they don't give you a graph that you can read the vertex off from, there's a formula that you can use that is equally easy. Well, maybe not equally easy, but it's still pretty easy. And it's this guy right here. X equals the opposite of b over 2a. And that comes from the quadratic formula. It's part of the quadratic formula. And like I said earlier, if you would like to know more about the quadratic formula, please look at the quadratic formula video. And I'll show you right where that opposite of b over 2a comes from. How I'm going to get the b and the a to fill into this little equation, this little formula, and how I'm going to get that is right out of the equation that they're giving me for my parabola. And the a, of course, is whatever, oops, you know what, there's a typo here. Should add a square into your notes. I'll try to fix that myself. So maybe I'll fix your copy before you get it, but I'm gonna have to add it in here. So there's an x squared added to this problem. I need that to know where the x squared term is, so I can figure out what a is. So a is going to be a -3/4. B is a -4. And I'm going to write down C, the constant term, out of habit. I'm not going to use it in this case, but I'm going to write it down anyway. And then I'm writing down the formula that I'm going to use. X equals the opposite of B over 2A. It's always a good idea to write down whatever formula that you're going to use before you plug numbers in. It does two things. It lets anybody know who's reading your work know what you're doing, but it will also help you as you do more complicated problems keep track of what the heck the numbers that you're finding are doing and what your thought process is. The side benefit, by the way, of writing them down every time is that it ends up helping you memorize them. So if you have difficulty memorizing formulas, this is a great way to do it. All right, so I'm going to use x equals the opposite of b over 2a. That's my formula. Now I'm going to plug stuff in. The opposite of b is -4. So I've got the opposite of -4 in the numerator. And a is -3/4. So 2 times -3/4. That's what x is. Well, that's looking a little messy, but I think we can clean this up a bit. X equals, a -4 is just a +4. And I'm multiplying fractions here. So 2 over 1 times a -3 over 4. Cancel out some 2's. And I'll end up with a -3/2 in the denominator. A complex fraction always looks weird to me, so I usually rewrite them. This just means 4 divided by -3/2. And if I'm dividing fractions, I really want to just multiply by the reciprocal, which becomes -2/3. So I'm multiplying 4 over 1 times 2 over -3, which becomes 8 over 3 negative. So looks to me like the axis of symmetry is x equals -8 over 3. And there's the equation. Just by using the formula, which is part of the quadratic formula.